Hello dear students, welcome back to Chandu Biology Classes, and in this session we will be discussing electrochemistry, and this session is highly helpful for all the students, those who are aspiring for IIT JAM BT as well as GATE XL. So in this session I will be covering all the important topics of this electrochemistry in relation to this IIT JAM BT as well as GATE XL, okay, and I will be solving previous year questions of IIT JAM BT also here, okay. So let me show you the syllabus first. So this is the syllabus that is clearly mentioned in GATE XL. So just look at the syllabus. This is the syllabus of GATE XL for this chemistry, okay. So now see conductance, Cold-Rush law, cell potential, EMF, Nernst equation, thermodynamic aspects and their applications, okay. So when it comes to IIT JAM, yes, almost same syllabus is included here. Now I will be showing the questions of IIT JAM BT that are from this chapter from previous year papers, okay, so that you will get some clarity, then we will start our discussion, okay. So look at this question, they are asking about standard potential or whether this reaction is possible or not. See here they are asking about standard potential of this cell, okay. I will tell you how can you do all these questions. See, these are the electrochemistry based question from IIT JAM BT, okay. Now if you already know the content, if you already prepared this previously, yes, just give a try for solving this. If you are not able to solve these questions, just attend this session completely so that you will get complete clarity on these questions as well as concept involved in these questions, okay, right. So these are some questions I just wanted to show you from IIT JAM BT, right. So now if you look at the questions, most of the questions are from standard reduction potential like E0 of cell, okay, something related to potential values, okay, right. So and their applications, okay. Let us look into this topic first of all so that you will get more confidence when you go through the previous year questions, okay, right. Now we will be starting from very basic first. Let me give you some basic introduction, then we will move forward, okay. So look at here, what do we mean by electrochemistry? So electrochemistry deals with conversion of electricity into chemical energy, or using this electricity we can make a chemical reaction or a chemical change, okay. So now what I am saying, there are two types here. So electrochemistry involves in two types of reaction, okay. So one is electrochemical reaction, another one is electrolysis. What do we mean by electrochemical reactions or electrochemical cells here? So now in these electrochemical cells, chemical reaction takes place. What I am saying, chemical reaction takes place and that will produce electrical energy. What they will produce? That will produce a electrical energy, okay. So now what type of chemical reactions are taking place generally? Here in electrochemical cells, redox reactions taking place. What reactions? Spontaneous redox reaction takes place that leads to generation of electrical energy. So a spontaneous chemical reaction is responsible in the electrochemical cell for production of electricity, okay. Remember this. Now we are going to discuss about this topic very deeply as per our syllabus, okay, right, and later we will be solving the questions also. Then next one more process is electrolysis, okay, and these are also called as electrolytic reactions, are the reactions in which this electrolysis is taking place. Now you can call them as electrolytic cells. Here I am saying electrochemical cells, these are electrolytic cells. Very important to remember the names here. I am saying electrochemical cell where a chemical reaction is taking place to produce a electrical energy, okay. When it comes to electrolysis cell, electrolytic cells, here by passing electricity, by what I am saying, by passing current or electricity here, a chemical process can be taking place. What I am saying, a chemical reaction is taking place with the help of electricity, a chemical change, a chemical reaction is taking place. It means here this chemical reaction might be non-spontaneous. What I am saying, this reaction is a non-spontaneous reaction. It means it is not happening on its own, whereas here in electrochemical cell a spontaneous chemical reaction is taking place. It means that reaction happens on its own. So due to that reaction, electricity is produced there. But in electrolysis or electrochemical cells, like electrolytic cells here in electrolysis process, what happens? Non-spontaneous chemical reactions are involving. So due to these non-spontaneous reactions, in order to make it a possible reaction, because non-spontaneous means it won't take place on its own. So what we need to do? We need to supply some energy, we need to supply some energy from outside, okay, that is nothing but here electricity. So by passing the electricity, we are making this non-spontaneous chemical reactions to happen, okay, to take place the product formation, okay. It means I will give you a simple example here. See, we know metals exist in their ore forms. How do they exist? Their ore forms, like minerals we are seeing, okay. When you extract it from earth, the metals will be mostly in their metal oxides forms right now. So now formation of metal oxides is a natural process. For a metal will convert into metal oxide form spontaneously, naturally, okay, it is a natural process. But what we require now, we require a pure metal. So it means pure metal can be obtained from these metal oxides only now, because in the nature how this metal exists in their oxides forms. So now what we need to do, we need to bring a non-spontaneous chemical change from its metal oxides to its metal state right now. So it means we are bringing this like metal oxide to metal by passing some electricity. By with the what help? By passing electricity, we are making this process to be happened here right now. So that is what a electrolysis process. What is that? Electrolysis process, okay. So in electrolysis cell, electrolytic cell, a non-spontaneous chemical reactions are taking place, remember, okay, with the help of electricity, okay. Remember the difference between electrochemical cell and electrolytic cells. So those guys who are in live, please mention everything is clear now here, whatever we are discussing. If there is any confusion, please mention in the chat box, feel free to interact. Yeah, so if this is clear, please click on the like button so that I can confirm that you are following the session, right. So now let us go through few more things before starting our concepts. Let us know these basic terms. So what do we mean by conductor? So conductor are those substances which allows passage of electricity through them, okay. So passage of electricity through them, it will be passing right now. So for example here, so these conductors are of two types, okay. One is metallic conductors, another one is electrolytic conductors, I can say, okay. What do we mean by metallic conductors? These are simple metals, okay. Metallic conductors are nothing but simple metal rods, you can say, like iron rod, okay. All these are what? So these are like allows the passage of electricity through them now. So metals like iron, copper, all these things if you take, so what do they have? If you take any metal, so in this metal, atoms of this metal are arranged in the lattice right now. So now in these atoms there will be nucleus, and around this nucleus mobile electrons will be there, okay. That electrons are loosely held to the nucleus, that is why metals are electropositive we are saying now. It means that valence electrons are very free to move here and there, okay. So now due to the free movement of these mobile electrons in the metal lattice, in the metal structures, so electricity will be passing through them, okay. So what is the reason for this metallic conductance here? It is a movement of free electrons or mobile electrons, movement of mobile electrons in the metal lattice, you can say, okay. And when it comes to electrolytic conductance, it means electrolytic means if you take NaCl salt, so NaCl in the molten state or in the aqueous state, it means you are adding salt to the water. See, pure water is a very poor conductor right now. So but when we add NaCl to this, what happens? So now NaCl, when it is in crystal form, see NaCl crystals, right. So when you are taking it in the crystal form, it won't conduct, but when you dissolve that NaCl into the water, what happens here? Aqueous NaCl solution will get. What will get? Aqueous NaCl solution will get. So now in this solution now we have Na plus ion and chloride ions. So due to the free movement of this chloride ion, Na plus ion in this beaker, now what happens? Electricity will be passing right now. So what is the responsibility, or what are the things responsible for electrical conduction in electrolytic cells? It is movement of free ions, like free cation, free anions are there. So due to the movement of ions, electricity is passed, or conductivity or conductance is shown by this electrolytic solutions, okay. Whereas in these metallic conductors, it is due to presence of mobile electrons. Just remember these two statements, okay. So conductors conductance in metals is due to mobility of electrons. So like electron C model will be there now. So that is what will be seen in the metallic conductance. And now you know metals may conduct electricity in solid, molten or even dissolved states, okay. And one more important point here is, with rise in temperature in metallic conductors, in metals with rise in temperature, magnitude of conductivity decreases or conductance decreases. Why conductance decreases? In this electron C model, it means here you have positive charge like nucleus, and along with that electrons, inner electrons are there, together I am calling them as kernels, okay. Now these are mobile electrons, free electrons, or mobile electrons is the best word we can use, okay. Like this again we have the beside one like this is a kernel, I can say. Kernel means inner electrons plus nucleus, whereas these are mobile electrons means valency electrons. Like this we have each atom with a kernel and this mobile electrons right now. So now what happens when we heat this, when we increase the temperature of this metallic conductor, like you take iron rod and you heat it up, okay. Now its conductivity value or conductance value decreases. Why decreases? Because this kernel will be having vibrations now due to increment in the heat. When you increase the heat, what happens? Kinetic energy of particles increases right now. So when kinetic energy is increasing for these kernels, so they will keep on vibrating. So due to this vibration, the conductance of these electrons will be decreases. Conductivity values for this will be decreases, okay. So with rise in temperature, conductance decreases. In which case it is? In metallic conductors. In which case it is? Metallic conductors. And now remember, when it comes to electrolytic conductors, what I am saying? Electrolytic, like normal electrolytic solutions, salt solutions, okay. So in case of salt solutions, as rise in temperature, like as you increase the temperature, conductivity or conductance also increases. If you increase the temperature, conductance also increases for electrolytic conductors. Why? Because when you heat the electrolytic solutions, for example, we know electrolytes are two types. Some are called as strong electrolytes and few are called as weak electrolytes right now. So when it comes to weak electrolytes, their degree of dissociation, it means formation of ions from this weak electrolyte will be more when you increase the temperature right now. So due to that reason, when you increase the temperature, these electrolytes will dissociate easily, and therefore more number of ions are formed and more will be the conductance for this electrolytic conductors, okay. Hope you got the difference between metallic conductors and electrolytic conductors. And one more word you can remember, metallic conductors are also called as electronic conductors. What I am saying? Electronic conductors. Metallic conductors are also called as electronic conductors, okay. Remember these terms whatever we are using here, okay. And let me explain you few more things. So these are the points I just wanted to add. So whatever we discussed, everything is mentioned here. You can take a screenshot of them and you can use it for reference, okay. Now let me explain you few more things. Now if you observe some metals, metals, let us discuss about some metals now. So if you observe some metals, like for example here I am writing lithium and magnesium, like this if you take, and zinc, like this if you write, all these are metals only, na? Right. But here if you observe, some metals are having more tendency to lose electron, like alkali metals have more tendency to lose electron and they exist in positive charge. We know all metals are try to be in electropositive nature, like they will show electropositive nature. It means they are having more tendency to release the electron and they exist in unipositive or their positive forms, like here it is unipositive, and here in this case magnesium plus 2 electrons, okay. So now it is losing 2 electrons now, so it is also existing in positive states right now, electropositive state. So here also zinc plus 2 and 2 electrons. Like this if you observe what you are getting here, so metals are electropositive and they have tendency to lose the electron. But out of these 3 metals, which is having more tendency to losing the electron? Always remember alkali metals, okay. Now the tendency to lose the electron or tendency to gain the electron by non-metals, see metals are electropositive right now. When it comes to non-metals like fluorine, chlorine, like this if you observe, so these are electronegative. What I am saying? Electronegative. So electronegative species have tendency to gain the electron. So now if you compare fluorine atom, chlorine atom, fluorine atom, and then next bromine, all these things if you compare. So now what happens here? There will be different scenarios you will be seeing, okay. So I will be writing for chlorine and bromine here. So between chlorine and bromine, chlorine is more electronegative generally we know. So now it has more tendency to gain the electron and become chloride ion, and this becomes bromide ion, okay. So now depending upon the ability to gain the electron, we will be having the one will be having more tendency to gain the electron, other one will be less tendency, right now. So here also one will be having more tendency to lose the electron, other will be having less, okay. Now how can we get this, which one is having more tendency to get gain the electron and lose the electron? How can we decide this? Yes, here we have a series called electrochemical series. What I am saying? Electrochemical series. So in this electrochemical series, for all these metals, they will be giving electrode reduction potential, standard electrode reduction potential, for each electrodes. It means lithium converting in lithium plus converting into lithium. So it means this is reduction potential. Now what I can say, oxidation potential means lithium converting into lithium plus, okay. So it means here Li to Li plus. See here, what is this process? Loss of electron. I hope you know basic terms like loss of electron is what? See, atom is converting into unipositive. It means losing the electron now. So tell me, what is this process called? Oxidation, right now. So now during this process, how much amount is released? I mean not here energy, but here we can say potential. What I am saying? Potential, okay. So here Li plus to Li to Li plus. So this is called standard oxidation potential of lithium, okay. Now when it comes to here, E naught of Li plus to Li, so this is reduction potential indication, this is oxidation potential indication. So more is the electrode potential value. What I am saying, more positive this electrode potential value. See, if oxidation potential value is more positive, it means that species have more tendency to undergo oxidation. Once again remember, if the element have more oxidation potential value, it means that will be having more tendency to undergo oxidation. If it is having more reduction potential value, that element or that species is having more tendency to undergo reduction. So now for all the metals, what I am saying, for all these metals whatever we have indicated, so their oxidation potential will be positive and their reduction potential will be negative. It means what I am saying, all these metals are having more tendency to undergo oxidation. So that's why their oxidation potentials are positive and reduction potentials will be negative. And remember guys, their oxidation potential, reduction potential will be having same magnitude but opposite sign. See, if this value is something like positive x oxidation potential, then reduction potential will be negative x. So same value but opposite signs for oxidation and reduction. So I can write here E naught of oxidation potential will be equals to minus E naught of reduction potential, okay. So based on this, now look at here, I will be showing you one table, okay. I will be showing you one table. I hope this table is very clear. So now if you observe in this table, in this table here you have lithium. So lithium plus is converting into lithium. So what is this process? Positive charge is converting into 0 means oxidation or reduction. Value is decreasing now, so you can say reduction. So by gaining of electron, Li plus is converting into Li, okay. Lithium ion converting into lithium atom. So now what is this reduction potential value? Minus 3.04. How much it is? Minus 3.04, okay. Similarly, if you go slowly upside like this, what you are seeing, so these are becoming less negative, and here it is 0, and above here you will be seeing positive values. It means from bottom to top, if you observe, all these things are reduction potential values only. See, Pb plus 2 is converting into Pb, it means reduction only now. See, Ni plus 2 is converting into Ni, okay. Cd plus 2, cadmium plus 2 converting into cadmium. So Fe plus 2, iron plus 2 converting into iron. So all these are what? Reduction potential values only. So from top to bottom, if you observe reduction potential values, here bottom is at negative, top is at positive. It means the one which is at the top of this series can undergo reduction easily. What I am saying, the one which is at the top of this series can undergo reduction very easily right now. So now out of this species which is undergoing reduction more easily? So fluorine, because F2 to F minus reduction potential value, if you see, this is plus 2.87 right now. So it means that is having highest tendency to undergo reduction. It means it is having highest reduction potential value. Okay. Now I am making few statements. The species or the ion or atom or molecule which has more tendency to undergo reduction act as strong oxidizing agent. What I am saying, strong oxidizing agent. Now out of this species which is strong oxidizing agent here, so F2 is the strongest oxidizing agent from this table. Why strongest oxidizing agent? Because this species will undergo oxidation and this species undergo reduction and oxidizes others. For example I am treating this, see here, so chlorine gas is chloride ion is there and I am treating this with F2. What I am treating it? With F2, fluorine. Now this will be like NaCl is there, we have NaCl and F2 molecule is there. Now it becomes NaF plus NaF and Cl2. So now what is happening here? So what is happening here? Chloride ion is converted into chlorine and F2 molecule is converted into F fluoride ion. Okay. So now this reaction is feasible and this is like possible reaction. Why I am saying feasible or possible reaction? Because fluorine is having more tendency to undergo reduction when we compare with the chlorine. See, chlorine is just 1.36 but fluorine is 2.87. So which is having more tendency to undergo reduction? So fluorine, so that's why fluorine will be in NaF like fluoride ion form and chloride ion will be converted into chlorine when we react with this. Okay, it means if I show this reaction and along with one more reaction NaF plus Cl2. So now tell me whether this reaction is possible or not. NaCl plus F2. So the second reaction won't be possible. Why it won't be possible? Because reduction potential value for fluorine is greater when we compare with any of the things here. Okay, that's why fluorine always will be acting as a oxidizing agent. See, what do we mean by oxidizing agent? See, what is happening to chloride ion? See, it is -1 now on chlorine, it is converting -1 to 0 oxidation state. See, -1 to 0 means what happening to the chloride ion here? So -1 is converting into 0 means what is happening? Chloride ion, anion is losing electron and becoming 0. So -1 is becoming 0 means by losing of electron only chloride ion is converting into this form now. So you can say chloride ion is undergoing oxidation to form chlorine molecule. Okay, so now chloride ion is undergoing oxidation and fluorine is undergoing reduction. So this species, the fluorine is a species which is making chloride ion to undergo oxidation right now. So those species which oxidizes others and reduces themselves are called as oxidizing agent. Okay, so from this table tell me which is strong oxidizing agent. Fluorine will be strongest oxidizing agent. Okay, now if you look at the down here, we have reduction potential value for lithium is negative. So reduction potential value is negative. How much here? Li plus 2Li. Standard reduction potential value of this species is minus 3.04. Then what about its oxidation potential? E naught of Li2 Li plus will be plus 3.04. Okay, so here if you see oxidation potential will be same value with opposite sign. Here it is negative, here positive. So it is having, lithium is having greatest oxidation potential right now. So since it has more positive oxidation potential, so lithium will undergo oxidation and reduces others very easily. Therefore you can say lithium act as a very good reducing agent. What I am saying, lithium can be a good reducing agent, very strong reducing agent and weak, very weaker oxidizing agent. Okay, lithium will be strong reducing agent. What I am saying, strong reducing agent. So you need to remember these values. Okay, I mean at least this order. okay. So I will show you two questions now based on our discussion, whatever we discussed till now, okay. So now look at here the very basic question first. Look at this question and tell me what is your answer for this. Which one of the following statements is correct for the reaction, for the given reaction? What is the correct statement they are asking? Very easy. So just tell me what you got from our discussion. What you got from our discussion? Yeah, so look at here, 2HNO3 plus a Cu, let me write the reaction also so that it will be more convenient. 2HNO3 plus a Cu plus H plus gives rise to 2NO2 plus a Cu plus 2 plus 2H2O. Okay. Now what they are asking, H plus is oxidizing agent and Cu is reducing agent. So read these statements. So what is happening here? So nitrogen in this case is in +5 oxidation state. I hope you know that how to calculate oxidation states. If not, please listen here, I will be explaining here. So HNO3 is there now. So for nitrogen you need to consider it as X value, okay, because we need to calculate its value right now. And here you know oxidation states are given based on the electronegativity difference. So why I am saying electronegativity difference? See nitrogen, oxygen. See nitrogen is central atom here. So these surrounding atoms, hydrogen and oxygens are attached to nitrogen. Okay. Now you need to remove all the bonds from the nitrogen towards the atoms, like surrounding atoms, based on their electronegativity differences. If surrounding atom is more electronegative, that bonded electrons are taken by that surrounding atom only. If surrounding atom is less electronegative, then the bonded electrons are taken by central atom only, like this. Okay. So based on that, X is the electronegative value for nitrogen, and here you have hydrogen. See, we know hydrogen is less electronegative than nitrogen. So hydrogen is a valency is 1, so it will be unipositive here, H plus I am writing. And the next one that is +1 charge I am writing. And next one, there are 3 oxygens. We know oxygen is divalent atom, so each oxygen, like oxygen is more electronegative than nitrogen, no? So each oxygen makes -2 charge. So there are 3 oxygens, so -2 here. So totally neutral, so equally to 0. So X value is how much? -6 plus 1. So it is -5. If you send that side, it becomes a +5. So nitrogen in this case, in nitric acid, is in +5 oxidation state. Hope it is clear up to here. Next, see, if any species is in their elemental form, the charge on that is 0, means it is oxidation state is 0. And here any species or any ion is existing independently, like Cu plus 2. Now whatever the charge present on it will be considered as its oxidation state. Now what is happening here, check. So copper 0 to copper plus 2. So what is this process called? See, loss of electrons now. So you can say this is oxidation process. If a species is undergoing oxidation, it will be reducing others. Okay. So this is undergoing oxidation, and you can say this is a reducing agent now. Okay. Next, what about here? So +5, and what about nitric oxide here? NO2 is given. So here +4 oxidation state. Now what is happening from here to here? So +5 is getting +4. It means number is reduced now. So reduction is taking place. What is happening? Reduction is taking place here. So this is the reduction. So if the species is undergoing reduction, so it will undergo reduction and oxidizes others. Therefore you can say this is a oxidizing agent. The one which undergo reduction can act as oxidizing agent. One which is undergoing oxidation can act as a reducing agent. Okay. So now H plus ion is, it is not involving either any oxidation or reduction process. It is same as it is. Here H plus only. Here also oxidation state of hydrogen is +1 only. So hydrogen is not involving in any oxidation or reduction process. It is just ion, being an ion here and there with +1 charge. Okay. Right. Now look at here. What they are saying. So H plus ion, no H plus ion here. So HNO3 is oxidizing agent and Cu is reducing agent. Yes, HNO3 is oxidizing agent because it is participating in reduction, and Cu, copper, see copper element like atom is a reducing agent, not copper plus 2 ion, it is only copper atom is reducing here. Okay, so here copper is reducing agent and HNO3 is oxidizing agent. So option 3 is perfectly answer for this particular question. Next, see copper is oxidizing agent, they are saying no, copper is undergoing oxidation, definitely it should be a reducing agent. So only perfect answer for this question is 3. Okay, clear now? If this is clear, please click on the like button. Those who are in the live session, if this is clear, please click on the like button, guys. Right, next discussion is here. Look at here, look at this reaction again, what they are saying, under standard conditions KMnO4 produce O2, very easy, do not scare by looking at the data they have provided. Of course you can use the data to make it more easy to solve. So look at here what they are saying, under standard conditions can KMnO4 produce O2 from water in presence of mineral acid. See, it means when KMnO4 and water is treated, so when KMnO4 is treated with water, does this water here oxide form O-2 for oxygen, so does this form can produce O2 gas or not, they are asking. Okay, this is what they are asking. Now what we need to know, so here what is happening to oxygen, oxygen is undergoing oxidation and manganese here +7 oxidation state should undergo reduction. Now look at their potentials here, what the potentials they have mentioned, given half cell potential for E of permanganate ion MnO4 minus 2 Mn plus 2 is 1.51 volt and E naught of O22 H2O is given as 1.22 volt. Now looking at the values we need to decide here. See here what is happening here. So the reduction potential value here +7 is converting into +2 now, this is the reduction potential value. So here O2 is converting into O-2, this is the reduction potential value. So which is having more reduction potential value? Yes, so this one is having more reduction potential, manganese is having more reduction potential value. How much it is? 1.51. So looking at this value, yes, we can say manganese can undergo reduction and oxygen can undergo, O2 can undergo oxidation. Okay, but what they are asking, H2O should be converted into O2, it means this is of reverse manner. So whether it is possible or not, how can you answer? So just look at here, Mn is undergoing reduction, see which is having more reduction potential out of these two, manganese permanganate ion only having more reduction potential value now, yes, it will undergo reduction and the remaining one will undergo oxidation, yes. So it means the one which is having more reduction potential, it means by looking at the values, the one which is having more reduction potential value will undergo reduction and the remaining should undergo oxidation. Therefore, overall value will be positive for that cell. Okay, so it means the reaction is possible. Why I can say reaction is possible? Because here positive value, this value is more, no? Yes, it will undergo reduction and oxidizes H2O to O2 gas. Therefore, this reaction is taking place. Why I am saying? Just look at the values. The one which is having more positive reduction potential value will undergo reduction. Okay, since manganese permanganate ion is having more reduction potential value than water, here this O2, therefore it will undergo reduction and oxidizes the other species. Yes, the reaction is possible. So that's why I am saying option 3 is your answer for this question. Okay, is this clear or not? Guys, is this clear or not? Right, if this is clear, let us move forward. Look at this one more question. For zinc copper cell, E naught value is mentioned as 1.1. It means there is something called electrochemical cells we have discussed. Let me explain once again what happens in electrochemical cell. Electrochemical cell. So electrochemical cell is a cell which converts, or is a device which converts chemical energy to electrical energy. What it will do? Chemical energy to electrical energy conversion takes place. So in this cell we have two compartments, one is called anode compartment, other one is called cathode compartment. Okay, so first one anode, next cathode. Okay, so in this anode and cathode we will be taking electrolytic solutions, like electrolytic solutions. For example, in anode compartment I am taking zinc sulfate solution. What is the solution I am taking? Zinc sulfate. Here I am taking copper sulfate solution. Okay, now in this zinc sulfate solution just dip respective metal rod. So this is zinc metal rod. What is this? Zinc metal rod. And here you can dip a copper metal rod, copper sulfate, so copper metal rod you can dip. Okay, so now what happens here is you are connecting this, you are connecting this, you are connecting this. Okay, so now here I am attaching one key also. This is key. Okay, the next what happening, see you have connected from anode to cathode. So now what happens here is electrons at anode, this is anode compartment I am saying now. So at anode oxidation takes place. What is happening at anode? Oxidation takes place. So how this oxidation is taking place? See, zinc is having more reduction potential value. What I am saying, zinc is having more reduction potential value, therefore it will undergo reduction easily, so that it will form Zn plus 2 to 2 electrons. Okay, now whatever the 2 electrons are coming from here, that will move towards this cathode. Okay, and here electrons are going now, so what is this called? Cathode. So in this cathode we have copper sulfate now, so from that I am taking copper plus 2 ion. Now this copper plus 2 ion will take 2 electrons, whatever the electrons coming this side from this anode, the 2 electrons are taken by copper electrolyte and converts into copper solid. Okay, now if you observe, yes, electrons are flowing from here to here, and therefore whatever the ions, cations are there, that is converting into atoms. Now what about anions here? So more anions will be formed here now. It means you have connected your connection from one side only, it is not fully filled. So in order to make it completion, to complete this circuit, I am just inserting one more call here. What is this? It's called salt bridge. What I am inserting here? This is called salt bridge. What is the use of this salt bridge? So salt bridge will fulfill the electrical circuit. Here it is, fulfill the electrical circuit. And in this salt bridge, what we are using in salt bridge? We are using electrolytic solutions like inert electrolytes. What are the examples of inert electrolytes? Like KCl and NH4NO3. You should not use any electrolyte, there should be some specific only. So why I am only preferring KCl or NH4NO3 here? Because the transport number of cation and transport number of anion, it means mobility of cation and mobility of anion will be almost same here. That's why when cation is moving this side, anion also moves this side with equal mobility. Okay, that's what we can say, transport number of cation and anion should be equal. Okay, those kind of electrolytes only we should be considering in this salt bridge. Okay, now that electrolytes are mixed with agar-agar, a jelly substance, so that pasty mass will be filled in this like U-shaped tube, that is salt bridge. Okay, therefore what happens, all this copper plus 2 ions are converting into copper atoms right now. So now out of this copper sulfate, what you are seeing here, copper sulfate, copper plus 2 ions are converting into copper. Now what about this sulfite ions? Sulfite ions remains as it is, means what happens here, complete solution becomes more negative, no? Because more negative ions are present. So if more negative ions are present, that won't allow the passage of electricity, the entry of electrons will not be allowed here, the entry of electrons will not be allowed towards cathode, it means cell won't work right now. So therefore if we neutralize this, then only electrons flow takes place this side right now. So for that purpose, whatever the cations we have in this salt bridge, so that cations will come this side and that will neutralizes this anions. Okay, so it means sulfate ions will be neutralized by the ions present, cations present in this salt bridge. Okay, that is what the mobility of ions we need to consider here, cation and anion. Similarly here what happens, all this zinc rod, this is zinc rod now. So zinc rod, what happening to zinc rod? Zinc rod is undergoing oxidation and forming, like giving 2 electrons, the 2 electrons are traveling this side, but here you are getting Zn plus 2, so it means positive charge now. So if it more positive charge is deposited here only without any movement, what happens? Solution get positive charge, so it won't allows the transfer of electron from here to here. So what we need to do, whatever the cations are forming, we should neutralize them. So that can be neutralized by anions present in the salt bridge, like that. Okay. Now what is the help of salt bridge? It will complete the circuit. What it will do? First of all, it will complete the circuit, and the next it will maintain electrical neutrality. Yes. So here it is becoming neutral, here it is becoming neutral with the help of cation and anions present in this electrolyte solution right now. So now what is happening here? Electrons are flowing from anode to cathode now. Now current flows from cathode to anode. So it will be flow of electrons and current will be in opposite direction all the time. Remember this. Now due to this flow of electrons, what is happening? There is some potential developed in this cell, in this electrochemical cell. There is some potential developed. I am writing E naught of cell. It means if I am doing this at a standard conditions, standard conditions means at 1 atm pressure and 298 Kelvin, okay, and I am taking 1 molar concentration for this electrolytes, okay. Then what happens here? E naught cell equals to E naught of here anode. What is happening at anode? Oxidation. Remember, whatever may be the cell, at anode oxidation takes place. E naught of oxidation potential, okay, plus, see what I am writing, E naught of oxidation potential plus E naught of reduction potential. Both of them are indicated for here oxidation potential, here I am indicating reduction potential, that is why I am using here positive symbol, okay. So but in the exam they won't mention oxidation potential, they may mention reduction potential also, but we need to be careful. I will tell you how to identify that, very easy. So here oxidation potential means how can I indicate? E naught of zinc is converting into Zn plus 2. This is oxidation potential indication. And reduction potential for this species, what is happening here? So copper plus 2 ions are converting into copper. So if you observe here, so 0 converting into plus 2, here plus 2 is converting into 0. So you can say this is an oxidation process, this is a reduction process, okay. That is why I am writing E naught of oxidation, that is in anode half cell, and E naught of reduction in this cathode half cell, that is it, okay. So this is how you need to mention the things, okay. Now in the exam they may mention directly oxidation potential, or sometimes just to feel you confused, or as a standard format they will give data, but the data will be only for reduction potentials. It means E naught Zn plus 2 to Zn. So tell me, this is oxidation potential or reduction potential? It is a reduction potential, right? So this value will be mentioned as 0.7476 volts, okay. And E naught, you no need of remembering these values also, they will give in the exam, okay. E naught of mostly they will give, okay. E naught of Cu plus 2 to Cu. So this is positive 0.34, okay. These are fixed values at the standard states, okay. Now you need to use this data and you need to substitute here. So what is these values you could say here? So tell me. So here I have written in the standard oxidation potential formats, but the data given in standard reduction potential formats. So you can make this formula. I already mentioned that. So E naught of oxidation potential will be negative of E naught of reduction potentials right now. So they will be having same magnitude but opposite signs. So here whatever the value they mentioned, you can write opposite of that value. Otherwise I will be making a formula here, see. So here also I am writing reduction potential. It means E naught of Cu plus 2 to Cu minus E naught of Zn plus 2 to Zn, okay. So Zn plus 2 to Zn, okay. So any of this formula you can use, but try to substitute the values as exactly as the concept, okay. So it means E naught. So this copper, so this reduction is taking place at where? Cathode now. E naught of cathode minus E naught of, this is at anode, E naught of anode, that is it, okay, minus E naught of anode, okay. Now what are the reduction potential values they mentioned? At cathode copper values is how much? 0.34, okay, positive 0.34, reduction, okay. You just need to look this. So what is happening here? Reduction, data also given reduction, so put as it is, okay. Now what is happening here? So here oxidation is taking place, before I have positive values here, but I just converted into reduction process, so that I am inserting negative, because here this is also reduction. So negative of negative means like this you can insert and you can simplify this, so that you will get 1.1 volt, positive 1.1 volt. So now what you got to know, when E naught cell value, when this E naught cell value is positive, reduction potential of that cell is positive, then you can say this reaction is taking place spontaneously. It means a reaction is taking place spontaneously. This whatever the redox reaction we have written, that is taking spontaneously, and this much potential is generated through the cell. Okay, how much? 1.1 volt of electricity or potential is generated through that cell. So whenever it is a positive value, yes, you can say it is a spontaneous process. Yes, we can make a cell using it. Okay, now how can you represent this cell? So first of all, write anode. Now anode is connected to cathode using a salt bridge. That salt bridge is indicated with a double slash. Okay, then next write cathode. So at anode what happening? At anode oxidation is taking place now. Now what are the species involved here? Zinc and converted into Zn+2. Now I am using a single slash here. Why this is used? Because here zinc is in solid form and here it is aqueous state. Whenever you are writing two different phases, so you should use a single slash here for making that phase is different. And then next double slash, this is at anode. Anode first, next cathode. So here copper plus 2 is converting into copper. Okay, so this is aqueous solution form and this is a solid form. Like this you need to indicate. Hope our discussion is clear. Now based on this discussion, I will be showing you some questions. Look at here from the previous discussion itself. Yeah, look at here what they are saying. For the zinc copper cell, E naught potential is how much? E naught of cell is 1.1 volt. If the reduction potential of copper plus 2 to copper is this much, then what will be the reduction potential for this Zn to Zn+2 to Zn? Very easy guys, what I told you. So E naught cell is equals to E naught of reduction, where it is happening copper plus 2 to copper, okay, minus E naught of at oxidation is taking place at anode right now. So either you should write plus anode oxidation or otherwise minus anode reduction potential. So that is Zn+2 to Zn, that's it. This is how you need to mention. Now in the question what they are asking about this value. It means this value they are asking. So what to do here? You just keep it here, I mean send this side and this one you send that side, because remaining data is provided right now. So E naught of Zn+2 to Zn is equals to E naught of Cu plus 2 to Cu minus E naught cell. Okay, I hope you got how I have written this equation from this one. Okay, right. So now what is the data they have mentioned for copper reduction potential? This is reduction potential is 0.34, and what about cell value, cell potential 1.1. So that you are going to get here how much? A negative of minus 0.76 volt. How much you will get? Minus 0.76. The reduction potential of zinc is how much? Minus 0.76. In the previous slide also I have given. So the same value we got here. So your option 1 will be the perfect answer for the question. Hope this discussion is clear. So those who are in the live session, if the discussion is clear, please click on the like button. So after this we will be discussing few more questions. Look at this is a different question from our discussion till now whatever we have did. So this is different. So what they are saying, a dilute liquid ammonia solution of alkali metal conduct electricity. Okay, what they are saying, so they have taken liquid ammonia. So they have taken liquid ammonia, it means NH3, this is liquid state. Okay, now what they are saying, so this liquid ammonia, when in this liquid ammonia they have taken one alkali metal like sodium metal they have taken. Now what happens here? So what happens here? So here sodium metal will loses electron, right? So it will become sodium ion as well as electron will comes out right now, place electron. Okay, right. So this is what happens. So this conduct electricity. Yes, this conduct electricity. Yes, assertion is perfectly correct. Why I will tell you. So reason also you just listen here. The electrical conductivity is due to formation of solvated electron. Yes. So now whatever the electron formed here, so around this we will be having ammonia. Okay. So that is what solvated electron. Then next, and also ammonia like metal ion also gets solvated. Around this metal also we will be having solvent molecules. What are solvent molecules here? This ammonia molecules right now. So now this will be see, ion is there, electron is there. So when we have charges, there is a possibility for conduction, right? So that is a reason. Yes, assertion, reason, assertion A and B, both of them are correct, and this is correct explanation of one. So you can say both A, B are correct and are true, and B is correct explanation of A. So you can say third option will be perfectly correct, because here we have cation and there is solvated electron. So both of them are charges. So they definitely they will make the conduction possible. Okay, they are conductors here. They conduct electricity, I can say. Okay, right. And after this, you need to know about the Nernst equation. Okay, what we need to know about Nernst equation. Okay, and before that, just look at this example. What they are saying, whatever we have learned till now about galvanic cell, you can use here. What they are saying, if Au plus 3 to Au is this much and Fe plus 3 to Fu plus 2 is this much, then E naught for this reaction is how much? So you can say E naught cell will be equals to how much? E naught cell will be equals to E naught of, so which is undergoing here, just look at this reaction, as per the reaction you can write. So Fe is converting into Fe plus 3 right now. So E naught of Fe plus 2 is converting into Fe plus 3. So it is undergoing oxidation, I am writing oxidation only. And next Rm here, E naught of Au plus 3 is converting into Au plus 1. It is undergoing reduction. Okay, right. Now what is the data they have mentioned for these? So for Fe plus 2 to plus 3. So did they given anything? Plus 2 to plus 3 they haven't mentioned. This is oxidation. They have mentioned a reduction value. So we know oxidation, reduction both have same values with opposite sign. So now what I am doing here, minus 0.77 volt I am writing, same value with a negative sign. Okay. Now what about this thing here, Au plus 3 to Au. So how much Au plus, this is how much? Minus 0.29, that's it. Okay. So now what happening here, 7, 12, 7 plus 9, 12 you can take, and here 1. So this will be how much? It will be how much here? Yeah. So 0 and it will become 1 here. Okay, that's it. So 1.02 or 1.06 with a negative symbol. So where do we have? So the nearest option is here, we have option 2. Okay, so that will be our answer for the question. Okay, hope this is clear. Is this clear or not what we did here? Okay, this is 6 only now. This is 6 only you can take. Okay, so 6 and 1, 3, 0, 1. Yes, so this will be your answer here, second option. Okay, right. Next one. Look at this, one more question from our discussion only, whatever we discussed based on this. So read the statement once. Standard reduction potentials for 3 different redox reactions are given below. Yes, for 3 different reactions they have mentioned reduction potential. It means all these reactions are redox reactions only. See, it is like this I am writing. See, Cl2 converting into 2Cl. So this is a reduction only now. So its reduction potential value is 1.36 volt positive. And the next one here, after this you have this one, iron Fe plus 3 converting into Fe plus 2 and value is mentioned as 0.77 V. Okay. And the next this one I2, this is I2 is converting into I minus, okay, 2I minus. So its value is mentioned as plus 0.53. Okay. So now what they are asking, under standard conditions Fe plus 3 can oxidize. Now Fe plus 3 can oxidize which are the following they are asking out of these 3 reactions. Now what we know, so what we know, if Fe plus 3 wanted to oxidize others, it should undergo reduction right now. So now we need to look at its reduction potential value. So the Fe plus 3 ion has a reduction potential value of 0.77 volt right now. So this is a value for reduction potential. Now if other species having reduction potential value lower than this, that will undergo oxidation and this will undergo reduction. Okay. So it means Fe plus 3 can oxidize, I mean Fe plus 3 undergoes Fe plus 3 can oxidize now. So Fe plus 3 will undergo reduction and oxidizes others if the other having lower value than this. Okay. So now only I2 is having lower value than Fe plus 3 right now. So it means Fe plus 3 can undergo oxidation and reduces I2 but not Cl2. Why not Cl2? Because Cl2 only having more reduction value now. So therefore Cl2 will be in reduced form only, it will not get oxidized with the help of Fe plus 3. Okay. So Fe plus 3 can only oxidize I2 but not Cl2. Now look at the statement. Look at the statement. Fe I2 to I minus 2 I2 I minus 2, yes, I minus 2 I2 but not Cl minus 2 Cl2. Why? Because so this chlorine only having more reduction potential value, therefore it cannot reduce, it cannot oxidize chlorine but it can oxidize I2 like iodine. Okay, I minus 2 I2. Okay, it means which option? Only first option will be your perfect answer. Just look at these values. If the value is highest, it can able to oxidize the lower ones. If the value is lowest, it cannot reduce anything, it cannot oxidize anything. Okay, because see Fe need to oxidize others means it should undergo reduction. So the reduction is possible for that species if it has greatest value. If it is having lowest value, it will not do. If it is having intermediate value like this, yes, it can reduces the bottom one but not the top one. That's it. You can remember this trick. This is the value. So now Fe plus 3 can able to reduce, oxidize the species which is below than it but not above than it. Arrange them based on the decreasing order. So if it is above, it cannot be get oxidized. If it is below, yes, they can be oxidized. That's it. Only first option will be your answer for the question. Okay, right. Next. Can you answer me this question? Given that the standard electrode potentials are like this, E naught of Cu plus 2 to Cu is this much and E naught of Cu to Cu plus 2 Cu is this much, and again Cu plus 2 to Cu plus 1 is how much they are asking. Okay, it's very easy. See, when Cu metal is there, it will undergo oxidation to Cu plus and it can again converts into Cu plus 2. Okay, now Cu directly converts into Cu plus, or it can directly undergo from Cu2 to Cu0 to Cu plus 2. It means these are the 3 possible ways we can write. Okay, I am saying for this, whatever the energy change, Gibbs free energy change as delta G1, this is delta Z2 and this is delta Z3. Like this you need to take. Okay, now what they are asking about, given that standard electrode potentials they have given. Okay, so now and they are asking standard reduction potential for one of this process. Okay, I will tell you. So here you can write Gibbs free energy is nothing but maximum work done. So here you can say maximum work done by the system as minus NF, that is charge into potential E naught cell. We are talking about standard now. So delta G naught is a standard Gibbs free energy change. So here F indicates Faradays, N indicates number of electrons. Okay, so NF E naught cell you need to take like this. Okay, so using this equation, wherever I have delta G1, there I can substitute this in delta G2 also, in delta G3 also. So I can simply write delta G3 is equals to delta G1 plus delta G3. Okay, like this you can write. Now in the place of delta G3, what you can write? Minus NF E naught cell, that is nothing but E naught 3 I am writing. Okay, and along with this what I am writing here, this one as minus NF E naught 1. Okay, and this one minus NF E naught 2, like this. But here Faraday's F value is a constant value, that is same all the sides. Okay, now here negative, negative, negative also removed. So you can write N E naught 3 is equals to N E naught 1 plus N E naught 2. Okay, so what is this N indicates here? N indicates number of electrons involved in that process. In G3 process, how many electrons involved? 0 is converting into 2 now. So here you can say N value is 2. Okay, so you can write 2 E naught 3, E naught 3. Okay, and what about in this process only one electron, 1 E naught 1, and what about this process? 1 electron, so E naught 2. Now what they are asking here? So they are asking about Cu plus 2 to Cu plus 1. It means Cu plus 2 to Cu plus 1, the reverse of this process. Okay, so they are asking about this value. So I am writing here 2 into E naught of what they are asking. First of all, Cu plus 2 to Cu is equals to E naught of Cu plus 1 to this data I have written, and this one is S1 to Cu, and the next E naught of Cu plus 1 to Cu plus 2, like this you need to write. So see why I have written like this. E3 is nothing but this process. What is that? E naught of Cu0 is converting into Cu plus 2, that is what the value I have written here. Okay, now look at the data what they have mentioned here. They are asking about Cu plus 2 to Cu plus 1. This data they are asking by mentioning other two data. Okay, so what you can say? 2 into, so Cu plus 2 to C is how much? It is 0.34. And what about this one? You just send this side and becomes minus Cu plus 1 to Cu is 0.522, and this will be equals to how much? E naught of Cu plus 2 Cu plus 2, that's it. Okay, Cu plus 2 to Cu plus 2 to Cu plus 2. Okay, so this becomes 0.87 minus 0.522. Okay, so it is given this much. Now how much you will get? You will get a positive value, and that positive value will be how much here? By looking at the values here, 780 means 8, 7, it will be 5, and the next 1, so 0.158. So where do we have? See, option 3 will be plus 0.158 now, so this will be your answer for the question. Okay, so this is how you need to do the questions related to Gibbs free energy or potential change. Okay, you should not take that they are asking about potential. You should not take like E naught 3 will be equals to E naught 1 plus E naught 2. If you take in this way, definitely it will be wrong. So that's why you need to use this equation, delta G naught will be equals to minus NF E naught cell. So this is how total energy, like total work done by the system is calculated. Okay, use that and you will get the answer in this way. Okay, and one more thing here, I just wanted to mention, because there are some questions asked on Nernst equation also. See, they are asking the value of equilibrium constant for an electrochemical cell reaction is 10. So K equilibrium is how much? 10. Okay, and its standard EMF is that cell EMF E naught of cell is 0.0148. Okay, at 298 Kelvin. The number of electrons transferred in the overall cell reaction. Very easy, I will tell you. There is something called Nernst equation. What I am saying, Nernst equation. Okay. So what is this Nernst equation? It relates electrode potential. See, till now we have discussed about standard potentials only. Now I am discussing about electrode potential at any temperature and concentration. So it means standard potential means what? I have mentioned it as standard cases like 298 Kelvin, like that 298 Kelvin, and concentration should be 1 molar, like that only we have taken. But here I am saying you can take this E cell calculation of potential at any temperature and pressure or concentration. Okay. So how can you get this? E cell equals to E naught cell minus 0.059 by n into log K equilibrium. Okay. K, here I am writing Q. So what is this Q? It's a reaction quotient. It means A is going giving rise to B if I say. So Q is nothing but B by A. Okay. If I say this is an equilibrium reaction, see how do we got this equation? This is might be the biggest question you have. So I will tell you the basic derivation also. Delta G means you can write Gibbs free energy is equals to delta G naught plus RT ln Q, you need to write here. Okay. Now let me give you the derivation, then you can use it for any reaction. Okay. So it means what you can write here, delta G means minus NF E cell. This is what we discussed in the previous slide, and here delta G naught now, so you can write minus NF E naught cell. Okay. And this is RT ln Q, like this you can write. Okay. And after this I want only E cell. So here you have a minus NF, here also you have minus NF, that can be cancelled and you need to divide here. So that gives E cell equals to E naught cell minus RT by NF ln Q. This is what you will get. So what do we mean by Q here? For a reaction A to B, what I told you, Q is nothing but concentration of product by concentration of reactant, you need to write. So now remember, at equilibrium, what I am saying, at equilibrium, so delta G value will becomes equals to 0, delta G equals to 0. If delta G is equals to 0, so E cell also becomes equals to 0, no? So because delta G is equals to this value, so if you send this NF that side, E cell also becomes 0. So it means this value also becomes 0. Therefore what you can make here, E naught cell will be equals to RT by NF ln Q. So now Q is called K, equilibrium constant at equilibrium. K I am writing here. Okay. K is what? Equilibrium constant. So now here R is the universal gas constant, T is the temperature they are asking for, and NF. Okay. If temperature is at 298 Kelvin and F is Faraday's. If temperature is at 298 Kelvin, F is 96500 coulombs, like coulombs you can take. Okay. That is what 1 Faraday you can say, charge of 1 mole of electrons. So simply by keeping all those values, you are going to get this value as 0.059 by N, because N is number of electron that depends on reaction to reaction. Okay. K, this is equals to E naught of cell. Okay. So now what they are asking here, if you look at the, if you compare this equation with the data given, they have given E naught cell, they have given K, and they are asking just about N value. So now I am writing N is equals to 0. Log you can write here 0.059 by N. N is how much? 0.0148. You can write this as 0.06 by 0.0148. So this is nothing but 60 by 1.5, around 1.48, that is 1.5 you can take. Okay. So it means, see I am writing, see just remove these zeros, that is 6 by 1.48, that is nothing but 60 by 14.8. So this value is how much? You will get nearest value as 4. Okay. Because 60 by 15 is how much? 15 4 ja 60, 15 4 ja 60 now. So it means 15 4 ja 60, that's why I am taking 4.8, 60 by 14.8 as 4. Okay. So you have option number 3, that will be your answer for the question. Okay, is this clear? So guys, is this clear? Whatever we discussed out of this Nernst equation, you need to remember this one final equation. So E cell is equals to E naught cell minus N minus 2.303 R T by NF log K. K means concentration of product by concentration of reactants, activity of product by activity of reactants. Okay, so now sometimes they will mention these values, you need to write there directly. Okay, so this is the thing. So if you put this RT as T is at 298 Kelvin, then what you are going to get? So E cell is equals to E naught cell minus 0.059. You by keeping all these values and cancelling out them, you will get 0.0591 by N log K. So this is what the equation you will get. Okay, so you need to remember this equation, because directly you can substitute here and you will get the answers. If they mention equilibrium, you take E cell value also 0, then you will get E naught cell, that will be your final answer for the question. Hope complete discussion is clear, right? So if you like this content, please click on the like button, also share with your friends, and you can share your feedback in the chat box. Okay, and you can also write whatever topic you are expecting from our side. The upcoming videos we will be definitely consider it, and we will be making videos on it. Okay, right. So thanks for watching. Stay connected with Chandu Biology Classes. Thank you.